In this video, we're going to take a look at a very powerful problem-solving tool called dimensional analysis. I mentioned in a previous video when I was discussing how important units are, that we can actually use units to help us solve problems. And that's what dimensional analysis is all about. Whether or not you know it, you know how to do dimensional analysis already. It's a fairly intuitive process. We're just going to learn now how to apply it to some problems that we'll see in a class like this. And so the example up on the screen now is a great example. If we want to know how many seconds there are in a day, actually what I'm going to do is just bring up my whiteboard and we'll walk through it together rather than looking at what's on the screen there. And so, and we'll go a step further. If I want to know how many seconds there are in 1 year, then let's think about how we're going to go about that. And so in 1 year, I know that there are 365 days. That would be my first step. From days, I can then go down to hours. I know that there are 24 hours in a day. And then I know that there are 60 minutes in every hour. And finally, 60 seconds per every minute. And then I can just go through, and I don't remember what that number comes out to be, but I can go through and multiply these. 365 times 24 times 60 times 60. And so I see that in 1 year, there are this many seconds. So that's, what's that, 31,536,000,000. We could express that in scientific notation if we wanted to. 3.1536 times 10 to the 1, 2, 3, 4, 5, 6, 7th. A note on significant figures is that this would be an accurate number of significant figures in this answer because these are all exact numbers. They're exact conversions. And so we treat them as having an infinite number of significant figures. So just as a reminder from our conversation in the last video. And so this is how we would get then from the number of years to the number of seconds. Every one of you would have been able to do this. Every one of you would have been able to come up with this number. I have absolutely no doubt. Now, this is the key to dimensional analysis. Every one of these steps here that we used, these are all what we call conversion factors. And that's really the key to dimensional analysis, is the use of conversion factors which allow us to convert from one unit to another. Now, let's say that I wanted to go the other way. If I told you that we have, and we won't maybe go all the way to years, but if I told you that we have 1 million seconds, and I simply want to know how many days is that? So I'm going to go back the other direction. I'm going to go 1 million seconds. Now, if we look back at our conversion factors that we were just using, our conversion factor to go back and forth between seconds and minutes is 60 seconds per 1 minute. Now, this is the power of conversion factors, is that I can write that conversion factor either way. I can either write it as 60 seconds per 1 minute, or I can think of it, if I can spell, as 1 minute per 60 seconds. Same thing either way. But I see here that now I want to use this, and I forgot to write my units in on this one. Bad, Professor Staples. 1 million seconds. And so what you have to figure out when using dimensional analysis is first you have to figure out what conversion factor to use. And so we know what conversion factor to use. We want to use this conversion factor now for this part of our problem. Well, we need to figure out which form of it to use, 60 seconds per 1 minute or 1 minute per 60 seconds. And what decides that, let's just write both of those out right here. We have either 60 seconds per 1 minute or 1 minute per 60 seconds. And so we want to use this conversion factor in whatever form cancels out the units that we want to get rid of and leaves us with the units that we want to still have. And so keep in mind some basic algebra. If we have, for instance, I'll switch up some colors here, just to get fancy. So if we have, without even looking at numbers, if we have seconds times seconds all over minutes, nothing cancels out, right? And we're left with seconds squared over minutes. That doesn't do us much good. So let's get rid of that. If, on the other hand, we have seconds times minutes all over seconds, seconds over seconds, anything over itself is 1. So that cancels out, and that leaves us with minutes. That tells us that this is the form of the conversion factor that we want to use here in our next step. I'm just going to get rid of these just so we can keep it a little clean here. So I want to use 1 minute for 60 seconds. And so now my seconds will cancel out and I'll be left with minutes. And now I can keep going. My next conversion factor between minutes and hours, I go through that same process. I know that I want to use this conversion factor right here. The question is, how do I want to set it up so that my minutes will cancel out and I'm left with hours? And so what I sometimes do is I'll write my units in before I do anything. I don't want minutes down here so that those will cancel out. And I want hours up top. And then I put in my numbers, 60 minutes per 1 hour. And then our last conversion over to days, you can hopefully see where this is going. 24 hours, so those will now cancel out per 1 day. And we see that the units that we have left with are days. And then your last step in any dimensional analysis is to do the actual math. The math of this is pretty simple. Everything up top gets divided by everything down bottom. And so when we plug in for the math of this, we're going to have 1 million times 1 times 1 times 1. And it's sometimes worthwhile if you're writing it out to include those, just so you can see what's going on. But then all divided by, down bottom, we have 60 times 60 times 24. I made my division sign a little longer than I needed to. There we go. And so then we can just plug this into the calculator just like this. And so if you've got a nice fancy TI, that's easy enough to use. You would simply go 1 million, then divided by, and then I would start my parentheses, 60 times 60 times 24, close my parentheses, and I get 11.57 days. And I'm just thinking about the way the sig figs would work out for this one. Technically, I only had 1 sig fig in my final answer, or my original question. So my answer could technically only have 1 sig fig, but we'll fudge it for this demonstration. But that's the power of dimensional analysis. Figuring out the conversion factors that you need to use, and then how you need to set those up so that the units you want to cancel out will cancel out, and the units that you want left will still be there. Sometimes we can use dimensional analysis in order to convert between English and metric units. Some of the examples we're going to see in just a minute are a great example of this, where dosages for medications are quite often given in terms of milligrams of the drug divided by kilograms of body weight of the organism receiving the medication. Yet we here in the United States typically measure the weight of an animal or of us in pounds. And so we have to be able to convert from pounds over to kilograms in order to find that dosage. And so we would use this conversion here, 2.205 pounds per 1 kilogram. So let's actually, and we're not going to worry about this energy example. I'll skip right through anything with energy. Actually, did I want to go back? I think this, yeah, okay. And so dosage, I had mentioned, is another conversion factor between the mass or the volume of the medicine and the weight of the patient. And so it's just another conversion factor. And so I had already mentioned that the units of it, but it's typically in milligrams of whatever the drug is, whatever the medication is, divided by kilograms of body weight of the individual receiving that medication. So it's just a conversion factor to go back and forth between the two. And we'll come back to dosage in a minute, but I want to point out another use of conversion factors is your metric prefixes and your metric conversions. You can also use conversion factors to figure those out rather than the methods that we talked about a couple videos ago. For instance, if I have maybe 2.3 centimeters, and if I want to convert that to meters, then I'm going to start out with my 2.3 centimeters. My conversion between the two is that there are 100 centimeters per 1 meter. And so then 2.3 divided by 100, I end up with 0.023 meters. So we can use conversion factors in order to do that. And in fact, quite often, that's exactly what I do, because it's just easier to set up in the body of a problem, because you can have a nice big long dimensional analysis setup and just throw your metric conversion right into the whole setup if you want. You'll see me quite often write dimensional analysis problems in a different way as well. I will quite often have a little setup like this, so 2.3 centimeters, and then my 1 meter. So I'll quite often set up this little grid, this little table, sometimes called the train track. Oops, see if I can get rid of that. There we go. Same thing, it's just a slightly different way to set things up a little bit. If you, I'll say you might have just heard, sometimes my kitty might make an appearance during some of these videos. This here is Rangeley. Say hi to everyone, Rangeley. There he is. Rangeley's a very good kitty. He just gets lonely and bored sometimes when I'm down here, and so he likes to come say hi. There we go. Okay. Let me just finish this, and then I will pay more attention to you. Okay. Another example of a way to use conversion factors is density. We've talked about density just a little bit, and it is in your book, but density is typically given in grams, units of grams per milliliter very often. Just another conversion factor. Let's say we know the density of a certain object is maybe 7.2 grams per milliliter. We know that we have 2.6 grams of that substance, and we want to know what the volume of that is. So we're just going to set up our 2.6 grams, our given information. Now we're going to use our conversion factor, the 7.2 grams per milliliter. Remember, that could be written either way. That could either be written as 7.2 grams per 1 milliliter or 1 milliliter per 7.2 grams. I'm going to use that however I need to for my grams to cancel out and to be left with milliliters. So we can see that I want to use this in the second way. So I've got 7.2 grams per 1 milliliter. And then I just plug that into my calculator, my 2.6 divided by 7.2, round off for significant figures, 0.36 milliliters. Simple, a way to use conversion factors. Let's look at just a couple of dosage problems to wrap things up. A couple things that we need to know just for terminology for dosage. You might see dosages written as QD, meaning once daily, or BID, meaning twice daily. And so very often, in the examples that we see in just a second, dosages are given out, or dosages are calculated as this is how much you would give the person per day. And so if you see the QD, then okay, what you calculate is that's what you give the person once per day, and that's fine. If, however, you see BID, then you know that that dosage needs to be spread out over two separate dosages, two separate administrations, I guess is the word. And so you would then divide that answer by 2, because you need to spread that out over 2 different times. So let's look at an example here. And so quinidine is an antiarrhythmic agent, something that will help with arrhythmias and different heart palpitations. The prescription for an adult weighing, or it is prescribed, so we have an adult patient, that weighs 110 pounds. The dosage is 25 milligrams per kilogram of body weight, BID. So the first thing that we want to do is express our dosage here as a conversion factor. So here's our conversion factor. So it's 25.0 milligrams of quinidine per kilogram of body weight. We also know, though, that it's BID, so this should be given twice daily. And so our last calculation, we want to know how much should be given to the patient at each administration. And so we're starting out then with our 110 pounds. That's what the patient weighs. Next, we do need to convert their weight over to kilograms. So we use our conversion factor between kilograms and pounds. And now we can use our conversion factor, 25 milligrams per kilogram of body weight. We plug this into our calculator, 110 times 25 divided by 2.205 tells us that the daily dosage for this medication would be 1,247 milligrams. However, this is given twice daily. It's given out BID. And so we need to divide that by 2. The patient would receive 624 milligrams twice a day. Here's one that I want you to try on your own. There are 2 separate problems here. So the typical dose of, what was that, ivermectin, I might be pronouncing that wrong, but it's a heartworm prevention for dogs, is 6.00 micrograms per kilogram of body weight once a month. I know for my dog, we've got to pop that into a little treat for him and he'll scarf it down. For certain dogs, though, that carry this specific gene, 100 micrograms per kilogram of body weight can be fatal. And so there's a couple things that we want to know here. The first question is, if we have a 95-pound golden retriever, how many milligrams of the drug should be given every month? Second question, we want to know what a toxic dose would be. We want to make sure that we're, if the dog does carry this gene, we want to make sure that we're not giving them a toxic dose when we give them this treatment. So go ahead and pause the video now, try both of these problems, use dimensional analysis, and see if you can come up with the right answer. Okay, for those of you that didn't actually pause the video and you're just waiting for me to show you the answer, I really mean it. Pause the video and try these. This is the way that you're going to get better. If this was a live class, I would be allowing you time to do this problem, and then we would look at answers. And so really do that. Pause the video, try to do this problem, see what you can come up with. Hopefully you came up with, for the first one, 259 micrograms is how much you would give this dog every month. Now try the second one. Let's see what a toxic dose would be if the dog happens to carry the gene. So again, pause the video and see if you can calculate how much a toxic dose would be for this specific dog. And we find that a toxic dose would be over 4,000 micrograms, 4,310. And so we're well within those limits. This dog is not going to receive a toxic dose if it happens to contain the specific gene. And so that will be fine. And so this was dimensional analysis. Dimensional analysis is, as I mentioned, is a tremendous tool to help us solve problems. I always hesitate to say this, but the reality is that even if you don't understand some of the chemistry of some things that we do coming up, if you can do dimensional analysis, if you can use this problem-solving tool, you can get right answers. And that's really the bottom line. I'll be honest, when I was in general chemistry several years ago now, there were some things that at first I didn't love chemistry and I didn't really pay a lot of attention, didn't get what I was doing. But I used dimensional analysis and I got right answers. There was also a class that I took once I realized that I did love chemistry when I was in grad school, a class on soil and aquatic chemistry. Great class taught by a geologist. And I forget the specifics of it, but we had a problem on a final exam that was essentially gave us all this information about a farmer's field and gave us just lots of different information about the soil and what was happening there, but also information about average rainfall and the average pH of the rain. And then we had to figure out and calculate how much lime the farmer would want to spread on the soil to keep it at a certain pH every year. And I'll be honest, when I got to that problem, I could not remember how we had talked about as a class to do it. No clue, completely drawing a blank. I filled up about 2 pages worth of dimensional analysis setup, just used units to guide me through the whole thing. I got the right answer. The professor looked at it later and said, no, but I was the only chemist in that class. It was mostly all geologists in there. Professor said to me afterwards, I've never seen somebody do the problem like this, but you nailed it. He said it was perfect. And so you can use this problem solving technique to get right answers. And so that's all for dimensional analysis. I hope you enjoyed.